Number 16 has a cosine of 3x on the left side, and that's actually what we're going to use to expand. And this one's a little tricky, but I think we've done a couple like it in class. So the first thing we're going to do is change cosine to 3x, cosine of 3x, into cosine of 2x plus x. And again, I'm trying to match the other side of my equation. So now that is going to allow me to use the sum identity for cosine. And if you're looking at your equation sheet, 2x would be your A and x would be your B. To expand this. We didn't know cosine of 3x, we don't have a formula for that, but we do have the formula for sum, and we do have the formula for cosine of 2x from the double angle formula. So we're going to use both of those in this proof. So to expand this, we do cosine of the first angle, cosine of our A, times cosine of our B, which here is x. And then in the sum formula for cosine, it's minus in between, and minus sine of our first angle, which is 2x, times sine of our second angle, which is x. So that's all expanded. Now the next thing I'm going to do is use the double angle identities. So I'm going to expand cosine of 2x, and that is cosine squared minus sine squared. Remember, you will be given those identities on the test. And then that cosine there is going to stay the same. And I'm going to do the same with the sine double angle identity. Sine of 2x is 2 sine cosine. And then I don't forget that you have that sine on the end there from the step above. So I just expanded using the double angle identities for both cosine and sine. And now we have a little bit of rearranging to do. The first thing I'm going to do with the cosines is here, distribute the cosine into these parentheses. Remember, we have to distribute. We always want to drop in parentheses when we're going to have a plus or minus involved. And here, since we have this minus in the middle here, we know we have to distribute our cosine in. So that's going to be cosine cubed minus cosine times sine squared. And over here with our sine of 2 sine x cosine x sine x, I can change those signs into sine squared. Remember, with multiplication, order doesn't matter, so you can write that in any order that you want. Alright, so we're getting close. I see some good things happening here for us in our problem. The first thing is I have this cosine cubed, which I have up here in our goal. I need 3 more of them, but I have cosine cubed. I also have some just cosines, and apparently I'm going to need 3 of those for my goal. So that's all good news. So because our goal is just cosines, I actually need to get rid of these sine squareds. And you know, the first identities that we worked with were cosine squared plus sine squared equals 1. And that's what I'm going to use here. I'm just going to substitute in for my sine squareds. Sine squared is the same as 1 minus cosine squared. So everything else is going to stay the same. And I'm going to substitute in 1 minus cosine squared. Again, I'm dropping it in parentheses every time. Minus 2 cosine times, again, replacing sine squared with 1 minus cosine squared. Now I have all cosines, so I'm just going to distribute and then combine like terms. When I distribute, my cosine cubed here stays the same. When I distribute my negative cosine in, be careful with your signs here. I get a negative cosine plus cosine times cosine squared is cosine cubed. And then I have this negative 2 cosine that I'm going to distribute in. So I have negative 2 cosine plus 2 cosine cubed. So there we are in great shape, and now we just need to combine our like terms. I have 2 cosine cubed here at the end, and I have 2 other cosine cubes in the middle. So I'm going to add a new page. You go ahead and combine the like terms as well. So that gives me 4 cosine cubes. And if what else we have going on here, we have negative cosine of x and negative 2 cosine of x, so that's going to give us negative 3 cosine x. And that is the same as our goal. And give yourself a big check mark because you proved the identity.